Welcome back, geometry students, to another edition of Your Notes, titled 9-5, Special Right Triangles, 30, 60, 90. Last time we did 45, 45, 90 triangles. This time we have 30, 60, 90 right triangles. And as you can guess it, there's a relationship that exists in that right triangle that we have. Okay, let's get to it then. Draw a 30, 60, 90 triangle. And this talks about the angles being 30, 60, 90. So it would look like this. Okay, it's a right triangle. Up top here would be 30 degrees, then I'd have 60 degrees on the triangle. All right, the relationship that exists with this one is across from the 30-degree angle, I have side x. All right, if I know what that is, across from the 90-degree angle is going to be double that, 2x. And then if I start with the one across from 30 is x, the side across from 60 is going to be represented by x square root 3, or x radical 3. Okay? So let's write that down. A 30, 60, 90. The pattern is x radical 3, and 2x. I'm going to use that again a lot whenever I solve those triangles. So look at that again. Across from the 30-degree angle is side x. Across from the 60-degree angle is side x radical 3, and across from the 90-degree angle is side 2x. Just like with the 45, 45, 90 triangles, all I need to do is identify the value of x, and I can fill in the rest of this chart, or the rest of this table. Okay? Let's do it together. Example number 1, I already have written down for you. If you'd copy this down, it asks me to complete the chart that's given. Okay? Example 1, complete the chart. I've got a 30, 60, 90, and any triangle that would use those angles, okay? And I want to complete this as it goes across. We should already know if one is x, okay? If I've got x there, then it's going to be x radical 3, and then I'm going to have 2x. Forgot to unfold these. There we go. It's nice. I've got 2x. Okay, so let's use some actual numbers. If my value of x is 3, then the x goes in that same spot everywhere here. So it'll be 3 radical 3, and then 2 times 3 will give me 6. Okay? See if you can look at this next one and do it on your own. Maybe pause the video and try and do it yourself, then replay here. If the side across from 60, which is always represented by x radical 3, is 4 radical 3, the value of x is 4, so across from 30 would just be 4. And then double that to go to the side across from 90, we get 8. All right? What if the side across from 90 is 10? 2x is represented by 10, so I can just find x by divided by 2. So I get 5 over there across from the 30, and then across from the 60 will be 5 radical 3. All right? And then what if I have a 60, across from the 60-degree angle, I have 12. All right, so x radical 3 is equal to 12. This one's a little bit more steps. I'm going to write it to the side here. If x radical 3 equals 12, or is represented by that, solve for x. Just like with the 45, 45, 90, divide by that radical. So divide by radical 3 on both sides. The radical 3 reduces out, so I have x is equal to 12 divided by radical 3. All right, remember, if I divide by a radical, what I'm doing is dividing by the number inside the radical sign and then putting that radical 3 with it. So 12 divided by 3 is 4, and put the radical 3 with it, so I get 4 radical 3. That's the side across from 30. So 4 radical 3 goes there, and that's the value of x. So the value of 2x would be double that. If I double 4 radical 3, I'm multiplying it by 2, so I do the 2 times the 4. I would not multiply what's inside the radical because I can only multiply radicals if I have 2 radicals together. So over here I would have, I'll write out 2 times 4 radical 3. All I'm multiplying is the 2 and the 4. So I get 8 radical 3. So that goes in there. Okay? And so completes my chart. If you can understand this chart and how I moved across all those numbers, when I apply it to a triangle, it gets simple. All right? Let's do example 2. Example 2, got a right triangle, and then 30 degrees is over on the side, and I've got 16 for that side there. Okay, a lot of times they have this diagram marked like this. They only give you the 30, But since this is 30 and this is 90, I know that this angle is 60 because all three have to add to 180. And I could subtract the 30 and 90 from 180 to get 60 left over. All right, every 30 to 60, 90 triangle is by 30, 60, 90, represented by x, x radical 3, 2x. Okay, and what I have here then is my angle 90, across from that is 16. So mark that in your figure, 16. So if 2x equals 16, solve for x, just divide by 2. 2x is 16, the value of x would be 8, and then the value of x radical 3 is 8 radical 3. So fill that in with the rest of the triangle then. Across from the 30 is 8, and across from the 60 is 8 radical 3. All right, one more example, example 3. I'm sorry, I've got 2 more examples. So example 3, let's see, I've got a triangle going this direction. It's a right angle. And this time it gives me 60 right here. That's all it gives me, okay? Well, I know this is 90, this is 60. I know I'm going to have 30 there. Okay, up top here I've got 9. So I know I got a 30, 60, 90 triangle. I can always start with this. 30, 60, 90 is x, x radical 3, 2x. Okay, fill in what I know. If the 9 here, I got to find out what side is that across from, or what angle is that across from, rather. That's across from the 60, so 9 goes there. All right, this time x radical 3 is 9. Just like up here, I can say x radical 3 equals 9 and divide by radical 3 on both sides. I can quickly see that if I divide by radical 3, 9 divided by radical 3, I end up with 3 radical 3. Okay, so x is 3 radical 3, therefore 2x will be 6 radical 3. So I can fill it in. Across from the 30 is 3 radical 3, and across from the 90 is 6 radical 3. It's cool how it only gives me one side, but yet I can solve for all three even without the Pythagorean theorem. Last one, example 4, as promised. All right, this time I have an equilateral triangle. Again, some words. Equilateral triangle. With a perimeter of 24 inches, find the height. Find height is what I said there, just to make room. All right, let's draw a picture of this. If I have an equilateral triangle, you should know what that means. Equilateral means they have equal laterals, equal sides. All sides are equal. If the perimeter is 24, I've got 3 sides, they're all equal. 24 divided by 3 gets me 8 inches on each side. All right. It says find the height. The height is going to go straight up and down here. When I drop that height in, also called the altitude, it makes a right angle with the base. This equilateral triangle originally had an angle, was 60 degrees, because I had 3 of them. All 3 angles were equal. 180 divided by 3 is 60. Okay. So if this is 90, this is 60, up right here, half of the 60 becomes the 30, and there I have a 30, 60, 90 right triangle. I can use the 8 inches on this one side to find the height. So 30, 60, 90, which is x, x radical 3, 2x. What side do I have? It's across from the 90 is 8. If 2x is 8, then x is 4, but be careful. To complete this chart, I get 4 radical 3 here. Which one is represented by the height? It's across from the 60. So across from the 60 is 4 radical 3, and therefore the height is 4 radical 3 inches, the height of this equilateral triangle. All right, guys, don't forget the WSQ. Hope you guys liked all those notes. Oh, and also, if you guys need more practice with simplifying radicals or multiplying radicals, there are a bunch of videos on YouTube. Just simply search it in, or maybe some will pop up after this one's done. Watch some of those. Hope you guys would take advantage of that, which is YouTube, to watch more videos, have somebody else explain it to you, and get better by it. All right, guys, have a great day.